Hey everyone, and welcome back to the second video in this lecture that we're going to continue. And this we will be plotting inequalities in two variable on the graph. So we already did one question regarding it, and this is the second example that we're going to start with in this lecture. So we have this inequality in front of you, that is y is less than negative 3 by 2x plus 4. So what is the first thing that we have to do? That first thing that we have to do is we have to plot this. And once we plot this, then we can continue with all the rest, that which part of the graph will be the shaded part, which part would be the which points are we going to use to test the inequality. As far as the plotting is concerned, I would suggest that you go by any method that you feel comfortable with. This slide basically shows one of the methods that could be used. That is, first you decipher it, basically break it down. You break down the equation, and you see that the gradient is negative 3 by 2. So that basically means down 3 and right 2. Of course, this is one of the ways of doing it, but since this lecture and this video series is not about plotting of the graphs, plotting of the equations, I would just say that you go with any of the methods that you know of plotting an equation, and you plot this equation. Once you have done that, basically one thing that you need to understand, of course, is that whether this is going to be a solid line or it's going to be a dashed line. This is one of the things that we figured out in the previous example, that this is what needs to be done. What needs to be done is that one of the things that the graph is going to show is whether the line is going to be a solid one or is it going to be a dashed one. Now we know over here that this is less than and equals to. Since it is less than and equals to, the line is going to be a solid one. The boundary line is going to be a solid one. So we know this now from the graph, and these are the points that you can basically use to draw the inequality. This is just, once again I would say that use any method, you'll get this answer. Now what is the second thing that you have to do? Now basically, once you have this inequality as a line, you know which part of the graph this passes from, and you know which part of the graph are above and below it. Once you know this, you can basically do that. You can basically check which part of the graph is going to be the shaded part, whether above this line or below this line. So now if you have in order to find that out, what you need to do is you need to basically find out by the help of a point. So you take a point over here, you take 0 0, try to keep it simple. You can take 1 1 1 2 1.1 and 2.7. You can take any points that you want, but try to keep it simple. That is the best and the quickest way to solve the equation, and that way you would make less mistakes as well. So let's just take let's just check 0 comma 0, and we will basically substitute 0 comma 0 in the equation. Once we have done that, we could know which part of the graph is going to be the shaded one. We just substituted 0 comma 0, and we basically saw through this that 0 is less than and equals to plus 4. So now, I mean, through this we know this one thing is certainly satisfied. You don't that this is less than n equals to 4. So now I know that there is a confusion that 0 is not going to be equals to 4, it's just less than 4. But this is how it is. This is how the convention is. This is how it is supposed to be done. So if 0 is less than or equal to 4, we know that this portion of the graph, since this is the portion of the graph, the one below this line, as we can see, or the left of this line, this is the portion of the graph that from which we are basically we basically took the point in order to test this test this equation as to which point of the equation, which part of the graph is going to be the shaded part. So in order to do that, we took this point, and now we know that the part below this inequality is going to be the shaded part. So we basically represent this inequality through this. I mean, the whole rationale and the whole logic behind the shading of the graph is that these are the values that are going to satisfy this inequality. These are the values that are being represented by this inequality. What that means is that these are the values in which y is going to be less than and equals to minus 3 by 2 x plus 4. So these values, the ones that show in the shaded area, are going to be the representative of this. Now moving on, where to shade? When y is isolated, there's a trick that we can use. So this trick that we're going to talk about is basically what I've already been talking to you about. Like, this is how it's going to be. Just use your intuition. This is how it's supposed to be. But of course, there are many. The best way, of course, is to take a point and plot it and to substitute it in the equation so that you can get the correct answer. But other than that, of course, there's this common sense that when y goes down, when we get less, so we have to shade below. Y goes up when we have more, so we shade above it. That we already saw from the equation, but that we already saw from the examples. But of course, I mean, just like the I talked about the plotting of the equation, you don't have to follow these conventions over here. Just do what suits you the best, do what you're most comfortable with, so that you don't make any mistake, and also you have fun doing it, and also the most important part, that you understand the concept behind all of this. Now, in order to do this, what we do is, we now, in order to conclude this series, we basically take an example, like sort of a real world example. Let's just say we have a rectangle ABCD with four sides, four corners labeled ABCD, which has a parameter of 10 centimeters. We need to find out a linear inequality that represents this situation. Okay, what is the first thing that we need to do? Now we know that a rectangle has one side which is longer basically than the other one. So basically it has a length and it has a width. So we're going to basically assign variables to both of these. Then we are going to write down the equation of the parameter. This is the parameter of the equation. This is the equation of the parameter, sorry. 2x plus y. That means 2 multiplied by one side plus 2 multiplied by the other side, since two sides of the rectangle are equal in their length. Having done that, now we know this, that the rectangle ABCD has a perimeter of at least 10 centimeters. At least means at the bare minimum it has a perimeter of 10. So what the equation we're going to write is, 10 is going to be, the perimeter is going to be greater than and equal to 10. That is what this equation represents, that at least it has to be 10, but it can be more than that, but at least it has to be 10. That's why we're saying that this part of the equation, that is the perimeter, this is known as the perimeter, 2x plus 2y is going to be greater than or equal to 10. That is, it's either going to be 10 or it's going to be greater than 10. It cannot be less than 10, because that is what the equation is telling us. That is what the equation asks of us. Of course, then we can do, once again, this is one of the points when you can use your own imagination, you can use your own knowledge and own concepts, and you can come up with the answer to this equation. Through that, you basically can find out the inequality that represents this fact. And the inequality that basically represents this fact is, it's pretty common. If you see over here, you don't even have to do this. I mean, if you take the two common over here, you're gonna get x plus y, and you divide that by 10, you're gonna get 5. So the way to go is that you use the simplest method. This is just a calculation shown so that just in case if you don't have to, if this is the way you're most comfortable with. Of course, we're going to get x plus y is greater than or equal to 5, but we already talked about in the lectures before, in the slides before today, that we need to isolate y. We need to put x on one side and y on one side. So in order to isolate y, what we do is we take the x to the other side, and the equation that we get is y is greater than or equal to negative of x plus 5. Okay, now another part of this equation basically asks us to graph this inequality. Now I would once again ask you to graph it in any way that you like, in any possible way that would make it comfortable for you to graph. Now all of these are basically points. This graphing that we are doing over here, these are just basic points. I mean, if you look at this point over here, this basically represents when x is equal to 0. When x is equal to 0, then y is equal to 5. Okay, and now this point basically is 1 comma 4. Basically, if we substitute this over here, we substitute 1 over here, we're gonna get y is greater than or equal to 5. So but of course, if we substitute 1 over here, we're gonna get y is greater than or equal to 4. So just like that, there are all the other points over there, and by plotting these points, what we do is we get basically we get one answer of a straight line, and we get a straight line that we can plot, of course. And once we are done with that, then we can after that find out which part to shade. Now this is the line that I drew. This is the line that is drawn on the slide. Now one thing to remember over here is that once again the very important part, don't miss this, is about the shaded part or the dash line. Since we have y is greater than or equal to, that's why we're going to have a solid line. Now we have a solid line. Now what is the third part that we have to do? I talked about three things that are represented that a graph represents. Those three things are basically, number one is the equation of the line. Number two is whether it is a dashed line or a solid line, and number three is the shaded area, which basically is a representation of all the points that satisfy this graph. So you have this graph, you've drawn it. Now how do we find out the shaded area? In order to find out the shaded area, we take the most simplest of all the points. The most simplest of all the points is basically 0, 0. So the most simplest of all the points is going to be the 0, 0, and we substitute that into 0, 0 into the equation. So what do we get? We get 0 on the left side and 5 on the right side. That would become 0 is greater than and equal to 5, which we know is not true, which we know is not going to be. So this way we know that the shaded area is not going to be the one which is below this line. In fact, the shaded area is going to be the one which is above this line, and thus we draw this as the shaded area representing all the values that is going to be satisfy this inequality. So this is pretty much it for linear inequalities. We still have two more topics left in this grade 11 math syllabus. We have the binomial theorem, which I'm going to start with next, and then we have principles of mathematical induction, which is basically not that hardcore math, but of course it is still necessary for you to make the concepts and understand them. This inequalities that we currently covered, we basically did inequalities as to what they are, how inequalities relate to us in math, how inequalities of a single variable can be represented on a graph, which is basically the number line. Then we talked about inequalities in two variables and how to find the solution of inequalities to two variables. The solution of the first of all, plotting of inequalities in two variables is done through these examples that we did over here. The solution to the inequalities is done by the shading. So the shading represents the answer to the basically the solution to the equation. So you have in front of you all the slides, all the videos related to the inequalities. This is pretty much it for inequalities. We'll be starting with binomial theorems soon. So hopefully you'll join me then as well. Thank you very much.